Özkan, are you ready to share your screen?
Yeah, totally. I'm ready. Uh, Not sure I'm in the right session though. I'm in education, so I'm a teacher. So
Oh,
we'll see.
okay.
It's related to, I don't know why I'm here. So
Yeah,
I like
sometimes.
to, yeah, I like to share my like system dynamic model that I use implemented in my classroom with the students first. Then you can see the model here. Then I can share my
Yep.
slide. So I'm Özgün Çetin. I'm a primary school teacher working in private IB school in Canada. So I'd like to share the early findings of our ongoing study of integrating system thinking into IB primary use program. So what is the IB International Baccalaureate primary use program? If I say PYP, it's primary use program. It's starting from 3 years to end of high school. So it's usually used in independent schools. It's a different kind of curriculum. So the PYP is designed, the IB designed to foster inquiry-based learning and develop students' academic, social, and emotional skills through transdisciplinary approach. While system thinking has been widely recognized for its potential to enhance students' critical thinking and problem-solving skills, there's limited empirical research on how it can be practically applied in IB and PYP classrooms. So our work in progress aims to address this gap by exploring how system thinking tools can be implemented and how they influence student solution quality, casual reasoning, and cognitive interaction. So bibliometric analysis in Web of Science, like a keyword was system thinking in primary school. So yielded on 23 publications indicating limited research on primary education. So the graph shows the distribution by year, highlighting underdeveloped field despite growing educational emphasis. So only two publications explicitly reference system, and none mentioned the IB, revealing no research connected to system thinking with IB, PYP. So these findings point to significant gaps, especially in practical applications for system learning tools and like different curriculum, especially in IB, PYP classrooms, motivating this study to investigate the impact of system dynamics interface on primary students, system thinking with the following research questions and solution quality. How does exposure the stock flow interface affect the quality of solution proposed by IB students for RLC sustainability challenge? To use casual reasoning, how do IB PYP students represent casual relationships in complex following interaction with a stock flow interface? For use cognitive interaction, what relationships exist between the complexity of students' causal diagrams and their ability to generate operational solutions. Um, so the study participants were 52 fourth grade students aged 10 to 9 years from a school in Izmir, Turkey. We did the same thing in Canada, but we're still working on that paper separately. So the students were distributed across three classes of approximately 17, 18 students each. All students in these classes participated in this study as part of their regular inquiry-based transdisciplinary PYP lessons and daily schedule. So the data collection process involved the administration of an 8-page booklet containing 20 questions designed to assess students' engagement with the soft flow model on that model and their comparison of other RLC system. So they run the model. They answer the question basically. So the
1 minute.
students sorry, 1 minute? Okay. The students completed the booklet during the lesson, responding to questions as they interacted with the model. So for the purposes of this study, three specific questions from the booklet were selected for analysis. These questions, 13, 14, 19, you'll see here. Um, Questions in the booklet. The booklet was completed incrementally during the lesson, two lessons. I think the questions related to interface were addressed promptly as students interacted with the interface, ensuring minimal delay between exposure to interface and responses to question 13 and 14. So commercially, question 19 was positioned at the conclusion of the booklet at the end of like two lessons. So resulting in temporal interval of approximately like 1.5 hour between the students' initial exposure to the questionnaire and their responses to the final question. So this design enabled to examination of both immediate reactions and the longer term reflections on the RLC challenge. Sorry, this is the last one. So, although the RL Lake interface initially elicited a relatively high number of operational solutions, this effect was not sustained. Operational solution decreased significantly while commonplace solution increased markedly. That was weird, but we'll see. One plausible explanation for this decrease is the classic maybe forgetting curve on students or like which says that approximately 53 of learning is forgotten after 1 hour, but it's not really possible. But we never know the students, so we don't know why we have this result. So it's kind of surprising for us too. Um, so the, like the regression results in indicates a statistically significant positive relationship between the number of variables and the number of relations. So the p values p equals 0.0133 indicates statistical significance at the alpha equals 0.05 level. So the positive coefficient 0.656 indicates that for each 1 unit increase in the number of variables, the number of relations increased by approximately 0.56 units, assuming that other factors remain constant. So commercially, the R squared equals 0.26 signifies that the model accounts for 26% of variability, and the dependent variable, the number of relations. So although the statistical significance of the findings is apparent, but the data indicates that 74% of the observed variance remains unexplained by the number of variables. So this suggests that the possibility that additional variables may be important for achieving a more complete understanding of the phenomenon. So these are our preliminary results, and we welcome any feedback or suggestion that can shape the next step of this research. I hope I was really sorry about it. Thank you for listening.
All right, thank you so much. So we have time for maybe two questions. Let's see if there's any questions online. I don't see any questions. So I can ask one.
Thank you then.
Sorry.
Yeah, please go ahead.
Oh
Yeah,
yeah.
please go ahead. Sorry.
Yeah, I was wondering about the the ILE. Is that the main tool that the students interacted with?
You mean the model?
Yes.
Yeah, yeah, yeah.
And I
That
was
was
yeah
the
I was wondering when I was reading your slides and paper, I was thinking like sorry, I don't if you mentioned the age group. I was wondering if it's like a really younger group of kids. I'm wondering if like you can actually make like a physical representation of this relatively simple structure. I thought that would be like a really fun learning tool, but I don't know if you kind of thought about, I don't know, applying the same lessons but in a different medium.
yeah, the students were like 9 to 10 years old, like a fourth grade. So they were really engaged in the lesson. So that's a different way of like seeing like sustainability to the challenge and the RLC. They were really shocked when they see the model. So they run the model. So I actually introduced the model and then we run the model together. But that after that one like approximately 1 hour, they run the model by themselves and then they answer the question by themselves. So they really engage in the model and they just figure out quickly, which was like, which why I'm like using my implementing system dynamic tool system thinking with my lessons. So they really engage in the lesson and they like run the model and they understand very well, and then complexity and then relationship between the events. So it's
Hmm.
that's the other way of that teaching
Okay,
my method.
great. Thank you so much, Oscar.
No worries.